Welcome back to the Minecraft tutorial. This is going to be part 4. In this part we're going to be going over breaking the blocks, and in doing that we're also going to make a basic interaction system so that we can see which block we are going to break, because currently we just spawn a world and we can't really interact with it. So the next step I want to do is to kind of give that interaction. To start today off, we're going to go into the player character and we're going to add some interaction. Let's go ahead with that. The first thing we need is obviously our player character, so we go to first person, blueprints, and open that one up. And for this we're going to need a few extra inputs, so let's go ahead and do those first. So I do believe they exist because we have the weapon one here, but we want to have IA left click and right click as well. So I believe shoot is already good. We want a boolean, but we don't want any triggers, so we're just going to duplicate it and modify it. So IA shoot, we're going to duplicate and we'll call it IA right click, and we'll then remove our trigger here. So we save that, and now we can duplicate it to get our right click, or our left click, sorry. There we go, let's just rename it, left click. And now just to make things tidy, we're going to add this to an input mapping we'll put here. So we'll just make a new folder for inputs, and we will make an input mapping context right here. IMC, we'll call it Minecraft, and inside of it we will add our input for left click, which will be left mouse button, and the same for right. So let's get it here, and right click. There we go. So we don't need this anymore. Now we just need to add it to the player. So I'm not sure where my begin play is here, but we will be adding it. So we're going to add begin play, and we want to add our inputs. So to add our inputs, we want to get enhanced input. Actually, sorry, no. First we want to get player controller. So this one right here. Then we want to get enhanced input local player subsystem. And with this, we can then call add mapping context. And the context we're going to add is the IMC we just made, so IMC Minecraft. So just to check if this is working, we will call our IA left click. There we go, and we'll do the same thing for the right, just so we can check that they are working. So on triggered, we'll just print our left, and on the other one we'll print right, just so we know that this is working. There we go, compile, save. So right now if we right click, and right now if I click it once, it does quick, but it's based on triggered here. So if started is just the initial click, triggered is when we hold it down, so that's left. So it's working. The next step we need to do is actually, in Minecraft, when you look around at different objects, you actually have a cube that appears around it. That's what we're going to be adding now, and to do that we need the event tick, because we want to do it as we look around. So event tick, plug this in here. We're going to start with our line trace, so line trace by channel, and this is going to be like any typical line trace. We're going to get our first person camera, we're going to get its world location to start, and then we want to get its world forward, and we're going to multiply that by the distance, like any kind of usual forward line trace you would do. So here get forward vector, and we can then multiply this by our distance. In our case we're going to leave it at 600, I think we'll do. You're obviously free to change this if you want the player to have more reach, that's fine. Then we want to add, connect these up, and put it end. There we go, so that'll do our line trace. Now just to check if this is working, we're just going to put for one frame. We're going to play, and we have our line trace. So it's not going infinitely far, we have a decent distance, we can reach a block over there, it's not too bad. Now we want to make it so that we interact, so we have a certain effect with it. So the first thing we want to check is if we have a hit. If we don't have a hit, we don't need to do anything, we don't want to handle extra information for nothing. So if we do have a hit, what we want to know is we want to know what we hit, and in our case this time we're looking for an instant static mesh. More specifically, we're looking for our block. So we're going to get from our hit component cast to ISM block. Now on true, there we go. Now, because of how it currently works, right? If we play this and we look at our environment, right here it looks like Minecraft, right? But what we need to know is if we go into wireframe, right here we have lots of blocks. Each individual block that we can see is an actual instance. So when handling that later, we're going to be kind of stretching these. We're going to be using a gritty meshing kind of technique, so that it's not just going to be 1 by 1, but sometimes it'll be 2 by 2, 3 by 5, whatever it can fit. So in that case, we can't just have, for instance, a get component size or bound and stuff like that, and we can't just delete a specific instance. We will need to adapt them. But for now, in our case, we just have this. We're going to add one that is just stretched so we can test it out later. So what this means is we can't just leave this and get our element index, which would give us the actual, not our index, our hit item, which would give us which instance we hit. Currently this will work, but later down it won't. So we're going to adapt it so that it does handle what we need. So we're going to have to save some of these right here as a variable. The first thing we want to do is we want to save this to a variable, because once we have it visible, we need to know once we actually click that this is a cube we want to interact with. So to do that, we're going to promote this to a variable, and we will call it hovering block. And just to make this all clear, I'm going to put this in a category for interaction. That way, anything that we make here is for the interaction system. The next thing we want is we want to save a few of these variables. So the first one we want is our hit item. So we're going to do promote to variable as well. And we'll call it hit item. That works just fine. Also put it in our interaction. Save all of these separately. Then we also need to get our normal hit, or our normal impact if you want. The reason for this is we need to know which direction we're hitting in case we want to place an item. Because if we're trying to place, then it should be above. If we're looking at above, if we're looking under, it should go under. So to do that, we need to promote this to a variable as well, which we will call impact normal. Work as well. Plug this in here. And we're going to need to use one final one, but we don't actually need a variable for this. So we're just going to grab our impact point and we're going to reroute it for now. And we can then collapse this. It looks like absolute spaghetti. That's why we made some of the variables, but we don't need this one, so I'm not going to do that. Just reroute these so it's at least a bit more readable. There we go. And just drag it past. There we go. So it's spaghetti, but it's readable. It's readable spaghetti. So on false, here, let's do this first before going any further, or on cast failed, we'll do the same thing. We're going to reroute, and on cast failed, we're going to call set hovering block to null, because having it be null means we can't interact with anything. Now, the next thing we need to do is, as I mentioned before, because when we're interacting, we might be interacting with a instance that is not 1 by 1 in scale. We need to do a bit more math than just hitting it, because from my testing at least, if initially I tried using our impact, but in some scenarios, because of how the collision works and how the coordinates work, you might actually you'll have hit it, but it'll be slightly off from the cube, meaning if you try to break it or try to place something, it will appear in diagonal from where it actually is, which is incorrect. So that's kind of a little bug, but we're going to circumvent that with a bit of math. So to do that math, we actually need to go into our ISM block first, because we actually need to add a function or two. So for now there's just one, but later we're going to have the second one. These comments are just me adding them in between the episodes. I haven't changed any of the code, it all works the same. So we're going to make a function here, and this function is going to be called get origin by index. And so the whole purpose of this function is it's going to take in the index of the hit result, and the index, what it will do is it will give us which instance we're talking about, and with that we're going to be able to determine its coordinates itself, that specific cube. So what we need is we will convert this to an index or an integer. So we'll call this index. And then we're going to, with our index, search for get instance transform. And we are looking for world space. We can then split off our instance transform. And here is where we need to do a bit of math because we actually need to take this into account. So we want to multiply this by 100. And the reason for that is because that's what the scale is. So turn this to a float and just put 100. We then want to reroute this and add these two together. Let's just line that up. There we go. And then we want to add them again. So pretty much what we're doing here is this here will get us the current location of that instance. And if you remember correctly, that location is 0, 0. So and if we look at our cube here, like this, the location will be the corner because that's where our, can we show that? Yeah, so here, so that's the pivot, so it's 0, 0, so it's in the bottom. So these coordinates right here are for this, they're for this corner. So what we're trying to do here is we're trying to get the other side. So we're getting our scale, multiplying that by 100 so it becomes an actual location. And then we're adding that to the start, meaning we're adding this distance to it. So then we have the start and we have the end. And then we just want to divide this by 2. To be fair, we could just multiply this by half. I believe we'd get the same result. Yeah, that could actually, we don't actually need to do that. We can just do it this way. So then we want to reroute. No, not reroute, sorry. We want to return node. And then we will plug this in. The return value, we can set this to pure. Compile and save, and we can go back to our player character where we're going to use this. We're going to take our hovering block and our hit item here, so both of these, and we're going to call our function get origin by index. And what this will do, now that we have it, we have our impact location and we have the center of the specific item that we hit. So with that, what we're going to do is we're going to subtract this from our impact right here. And this will kind of give us a direction. So we're going to normalize this. And now we have a direction in which our impact goes towards the center of the cube. So what this means, it will always be going towards the cube, unlike, for instance, our normal, which could have been outside, which would cause issues. Here, we're sure that we're heading towards the inside. And so with that, we can then add this, because usually the offset is very small between where we actually hit and when we'll be outside. So just doing it by a normalized vector is enough to bring it inside properly. So that way we can then round out our values to make a cube of sorts appear where our mouse is. Or where our cursor is, more like where we're aiming. So we add these two together. Let me just line this up with that, preferably. There we go. And so with this, there we go. We then want to say divided by 100. And the reason we divide this is so that we get kind of cubes, because that's what we're working with. So we then want to break this, and we're going to be remaking it. It's just that we need to make sure that this is rounded. But we specifically want to floor. And the reason we want to floor is because of how this is set up. As I showed earlier, our cube is aligned to the bottom. The pivot is aligned to 0, 0, not 50, 50 in the center. So that means we need to floor so that we have the correct values. So then we can return these back to float. So float. We'll just remake our vector here again. Like this. There we go. Vector. And with this vector, we are then going to multiply it by 100. So right here, float, not a double, just normal. Float 100. And we can then add 50 as well. And the reason we add 50 is so that it's in the center. And so to finish off, one thing we do need first is this is actually the coordinates of the block we're hitting. So these are actual coordinates here that we have. So I want to promote this as well, and this is going to be hovered coordinates. And we need that because later we're going to be modifying this specific block or this specific component based on that location. So with this, we then can do box trace by channel right here. So this is going to be start, and this is going to be end as well, because we don't actually need any collision. We don't care. What we want is we want to actually see the debug. We want it for one frame, and we want it to be black. And once we're done here, we can actually show it and see we didn't give a half size. So half size of 50, 50, 50, half of an entire cube. Compile, and let's try again. And now we have our actual cube. So as you can see now, when we interact, it always goes towards the location we're aiming at. And before, so the error we used to face, or I used to face before, was if we went and did this, it would kind of create a new cube to the left here above ground, which isn't correct, but because of how the impact point works, it would consider it outside, so it wasn't correct. So that does it for displaying our interaction. Now we just need to make it so that when we left click or right click, we place and remove. So in this video, we're just going to be doing the breaking. So let's get started with our breaking cube. So the first thing, we're going to move this down a bit. Just need a bit of space. There we go. And then we're going to do our right click next time. So that's going to be next part. This is what we're going to be focusing on today. So just expand this because we're going to need 2 of these. So right here, there we go. The first thing we need to save is we need to know how long we are pressing the button, because this is mining. We're not going to instantly destroy it. We want to break it slowly. So elapsed seconds needs to be saved. So we want to promote this to a variable we will call elapsed time. There we go. Put this on triggered. And then what we need to check is we need to know if hovering block is still valid. And the reason we do this first is because based on this, if he's holding the mining button, we need to actually take that into account. And if he changes block, we need to know when he changed block while holding. So that's why we do this even though this isn't checked yet. So plug this in here. And then we want a sequence. And so now we're going to need kind of 3 functions. And these 3 functions are going to be start mining, update mining, and finish mining. So the first one, we start mining. It's going to take in the elapsed time we just put. So it's going to be right here. So this will be start time, we'll call it. And that's actually going to create a new variable in a second. But first we'll make our 3 functions. Then we want to actually, we'll duplicate this. Duplicate, and we'll call update mining. Go. And finally, one last one, which I believe this needs to be a boolean, but we'll just duplicate it. This is finish mining. There we go. So this will be a boolean. And for this, what we want it to call it is success. And what success will do is if it succeeds, we break. If not, we cancel and reset. With that in mind, let's just build out the framework and then we'll go into the smaller functions. So one thing we need to do here is we need to do a do once, because this can only be called on the first trigger. We don't want this to happen every time, we just want it to happen once. So to stop that, here we're going to make a custom event to say that we can reset. And this is going to be CE because I use CE for custom events. Reset do once. This is specifically used if we succeed and we need to start mining again. So what we do here, we can then call start mining, because this will only be called once on begin. And as I mentioned before, we have to do this on triggered, we can't do this on started, because if you change from one block to the other, we want it to actually keep mining. We don't want it to bug out and just freeze up because it's not starting to click. So start mining, we need to know our start time. That's going to be elapsed time, right here. Now on the second one then, which is going to be all the time if this condition is already done, we're going to update mining. this, and this is also going to take elapsed time because at the end of the day it's still from here. And sorry, so we need a branch here as well at the end. So we need a return node. It's going to be restart. And so that's to say that we finished, we succeeded, so we then get to call our reset do once right here. And so to finish off, we have the completed. So this is another sequence here. And for this, it's very simple. If we let go of left click, or yeah, if we let go of left click, we want to reset our do once. And then we want to say that we finished mining, but that we failed. So we'll leave this false. And so now we can move into actually making these different functions. The first one is we'll do with start mining. Now start mining needs to first save this as another variable, and not a local one. It needs to be promoted to a normal variable. This will be initial elapsed time. There we go. And we also need to know right here we're going to get our hovering coordinates, which is for interaction, sorry. And we're going to promote these to another variable, which will be the start interaction. So we'll call it initial as well, coordinates. There we go. And we're going to put all of these into another one, which we will call mining. There we go. So put all three of these in that category. So I want to save this as well. And so right now we don't have anything for this, but we're going to make a decal in a second, but first I'm going to go through the process of breaking and then we'll do that. So here we're going to add the damaging effect, so to speak. Actually, no, you know, we'll do that now, actually. Yeah, we'll do that now. So before we do anything further now, I'm actually going to have to make our damage. So to make our damage, what we're going to do is we're going to use a decal system. And because of how the greedy meshing works, we can't, or at least I'm not good enough in materials, to make it so that our damaging only appears at the specific coordinate where we're actually breaking. So to avoid that risk, I used a very simpler method because at the end of the day, you're only ever going to break one block at a time. So this shouldn't be too expensive and shouldn't cause any major issues. So in our materials, we're going to right click. We're going to make a new material. We'll be calling m_damage. And so let's open this up. To make things easy to see, we're going to make this a plane, and then you can see how it works. It needs to be changed material domain to defer decal. That's what it is. And it needs to be translucent. So now we want to get our two texture samples, or two textures that we already have, which are the damage alpha and the damage color. So right here, like this, there we go. So this one is the color and this one is the alpha. So we want to multiply this by whatever we want. So here we're going to have a color plugged in, and it's going to go to base color. Sorry, it needs to be a 3, not a 4. Plug it in like that. And in my case, I put this to 0.5. But we can also make this a whatever color you want. Now, currently, obviously, we have our kind of white, but we don't want that. So that's going to be fixed by simply the alpha mask. So now we need to multiply this as well by a scalar. And that scalar is going to be called progress. And that progress is what will allow us to see, based on, because it's an alpha mask and I made it so that it scales, it'll allow us to see how far we are along the damaging. Now, actually, one thing, we need to put a 1- here first, otherwise we won't get the effect we want. It will go the other way. So that's my mistake once again, because I'm not an expert in materials. So here what we want is an if. And the reason we need that is because this by default is just a grayscale, and we actually want this to be 100% visible on the locations that are actually visible. So to do that, so let me just put that to 0.1. We want to say if it is superior or equal, we want to make it equal to 1, meaning that it's 100% visible. If not, then we want it to be equal to 0. So now if we look at this right here, so we start previewing, we can't see anything. Or maybe other way around, we can see everything. So I'll just put this in opacity for now. Okay, yeah, so right now we can see everything, but if we put, I believe, 0.9. Oh, sorry, no, that's my bad. So we don't want to multiply here. We want RGB to go into A, and we want our progress to go into B. So now progress 0.9, it's almost finished. If we put 0.1, it hasn't even started. And we put 1, and it's finished. Now, in our case, we're never going to reach 1, because 1 would mean everything is visible. What we want is 99, and we get the whole block done. Like that. So 99.9 is too close, but 99.5 will get us pretty much everything damaged and visible. And so we'll get to move this variable in an actual blueprint we're going to make right now. So with this, we now have our damaged material. So we can close this and close that. We don't need it anymore, so we can save. And we go ahead and we have a new blueprint now. And this blueprint is going to be an actor, which we're going to call A_damage decal. There you go. And so to test this damage decal, we're going to add a static mesh right here. And the static mesh is going to be our IMP, if I can write that, cube. So this is the size we're trying to break. Because even if we're trying to break a bigger one that's scaled, it doesn't matter. We're only breaking one cube at a time. So very simply, we're going to get a decal, and we're going to add that decal to this situation. So we're going to add our M_damage, like this. And it's working just fine. We want to make it a bit smaller, so here you want to make sure you put the same values as me. So this is going to be unlocked. We want it to be 0.5, we want it to be 50 and 50. So 0.5 being the thickness and 50 by 50 being the sides. So with this, we're going to actually make the top one first. And the top one needs to be 50 on the X. It needs to be 50 on the Y. It needs to be 100.25 on the Z. And we're going to rotate it by 90 on the Y. And so this is the result we get once it's fully breaking. And now we just need to rinse and repeat for every other coordinate. So we'll attach this here instead of on the static mesh. And we'll then duplicate this. Actually, we'll rename you to top. This one will be bot. And bot is going to be the same thing, except it's going to be minus 0.25. So now if we look below, it's there as well. And then we just want to kind of repeat this for every direction. So we'll duplicate top again. This will be front, call it. So front needs to be 100.25 on the X. And it needs to be 0 here. And needs to be, I believe, 50 on the Z as well. There we go. So now we have the same effect. We will now duplicate it, put it to the back. And this is going to be minus 0.25 again. And we will do the same thing, but for the left and right. So this will be right, and this will be 50, but 100.25 here. And we need to rotate it 90, I believe, on the Z. There we go. So 90 here. And we then want to do one last time for the left. And we'll move this to minus 0.25. There we go. So now we have our damage. Now we're going to remove the block. And now we don't see anything anymore, but it is still there. So what we need is we need to now modify these. So the first thing we need to do, and this is we can do on construct, works just fine. We're going to create a dynamic material instance. So create dynamic material instance. And that way we can actually modify the actual values. So we're going to put M_damage for the material. And we then want to promote this to a variable, which is going to be dynamic material. With it by default, we're going to set scalar parameter value, and we're going to set it to 0. It's going to be our progress. And then we're going to get all of these, every single one of them, and we are going to set them all. So set decal material, plug them all in, and we're going to plug it all into our dynamic material. Now, obviously this won't be visible yet, but once we start displaying it with our breaking, it'll be visible. So the last thing we need to do is we need to make a quick function for updating this variable. That way we can reference it more easily. We're going to say update damage, and we'll just copy this because it's pretty much the same thing. We just want to do this right here, plug in the value, and the reference is our dynamic material. There we go. That's all we had to do here. Now we are done with this. We can close it. We shouldn't need it anymore. So let's close damage decal and go back to first person. Now here we get to actually say spawn actor from class, and we're going to spawn our actual damage. So damage decal, we can split the transform, and we will plug in the initial coordinates to it right here. Actually, sorry. No, we can't plug that directly because by default that is block coordinates. So we need to just convert this to world space by multiplying by 100. There we go. Compile, and so with that, if I'm correct, so now by default it'll be 0, so it won't be visible. So we just need to update mining to be sure that it's working. So update mining is next. So with update mining, this is no longer start time. This is updated or current time. To be fair, we don't actually need this because we have the actual, if we go to here, we're using elapsed time, which we already have anyway. To be fair, it's the same in both of these, so we'll just get rid of it here for now. So back in update timer, first what we want to do is we actually need to go back to start because I forgot. We need to promote this to a variable. So this will be our damage decal right here, and this can also go to mining. If damage decal is false, we just want to say that something went wrong, and we'll just say false here. One other thing we want to check is that as long as the coordinates are equal, so that means that our initial and our hovered coordinates are equal. Like this, as long as these two are equal, we can keep going. If not, we want to destroy damage decal, so say destroy actor, because we've already checked that it exists, and we'll then return that it needs to restart because something went wrong, we want to restart, or that the coordinates are different, we want to restart. Next one we need to do, assuming this worked, the first thing we can do is we can actually say, well, update the damage decal. So update damage. And in doing so, we're going to make a formula that will allow us to immediately also know if we have finished the damage. So we're going to get our input pin, or in our case, the elapsed time here. We're going to say minus the initial elapsed time. And we're then going to say, well, we'll divide this by however long we want. So if we want to take 1 second to break it, then this is 1. If you want to make it 2 seconds, then that's 2. And because of how I did a very bad job with my photoshopping here, and our actual decal is a bit buggy and won't work smoothly through the damage, I just decided to add 0.2 here because otherwise it kind of doesn't work visually. We then want to clamp this value because we don't want to go above 0, as I mentioned before. So this will be 0 and 0.995. We can then plug this into value, and we can also check if ever this is equal to our last value right here. Then we can say branch and condition, and this will simply be to say, well, we finished, we succeeded, so finished mining, and it is true because we succeeded. We can then say return value, that it is true that we succeeded, and if not, because we haven't and we're still mining, leave it at false. So we can compile this, and all we are left to do is the finished mining. And the finish mine is rather simple. We'll add a branch here on success. If we succeeded, we want to remove the decal. So say destroy actor right here. And if we failed, we want to get our damage decal. And if it is there, then in that case, we want to say destroy it. Now with this currently, we can go ahead and mine, we can go ahead and test this, but we won't actually be able to destroy the block yet. We don't have anything for that. So if we click, you can see it gets damaged. Over a second, it breaks. As you can see, it's not smooth, which is kind of the issue because I did a shit job with Photoshop. And there we go. So it keeps breaking, it will keep repeating. If we move, it will remove the old one and restart. Doesn't mind, it will always restart when we change block. And obviously, as I mentioned, it's not actually getting rid of the block yet. So that's what we need to do now. And to do that, we're going to use a blueprint interface. So we're going to go and make that. So right click, we're looking for blueprint and blueprint interface right here. So this will be BPI interaction, because we're also going to be using this for the clicking, the right click for placing an item. We're going to start with our simple mine block. There we go. So mine block, what it needs to do is it needs to take in 3 inputs. First one is going to be what block are we targeting, so ISM block. The second one is going to be the coordinates, so this is going to be a vector. We need to know what coordinates we're trying to break. Then we need to know the hit item, so so an integer. All the way to the top. There we go. So the new parameter is our target for the block. The second one is the coordinates. And the third one is the instance index. There we go. So with this, in our player character now, we get to say here, we can say we can say mine block. Now the target is going to be, so we need to get from hovering block here and say it instead. So mine block. No, that's me being stupid, sorry. We don't need the second target. We already know the target because we're telling that it's going to be self. So let me just refresh this. There we go, target. Coordinates we already have. It is the initial or the initial coordinates we want to use. And then we want to use the hit item, which is our index right here. So with this load, nothing will happen. But what we need to do is we need to add that interface here in ISM blocks. So in our class settings, I believe, or is it in class? No, it's in class settings. We are looking for implemented interfaces, and we're going to add our BPI interaction. Okay, so because this video is getting rather long, I'm not actually going to cover the entire damage system or breaking. What we're going to do for today is we're just going to simply break the actual block. That way you get the satisfaction of completing it, and the videos get to stay kind of short. In the next part, if we have enough time, I think I will cover initially the breaking the block if it is more than 1 by 1. But for now, what we'll do is we will simply destroy the actual block itself. So let's do that. So very simply here, we're just going to say remove instance. And the instance we're going to remove is very simply this one right here. And so now if we go and break our block again, we should have it disappear. There we go. It's working as planned. And if we hold it, it will keep breaking as far as it can reach. And here it can't go anymore. Same thing here, and so on. So that does it for breaking the blocks. I hope you enjoyed this part. In the next part, we're going to be working on placing blocks, but also in the case of breaking, we'll try and implement the breaking of larger blocks, because here it's just 1 cube anyway.